myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study what are the terms are useful in drawing the cam profiles. So there are various terms are there in order to draw the cam profile. Number one, that is a base circle, and second term is the tracing point, third term is pressure angle, and the next terms are what is the pitch curve, what is the cam profile, what is the pitch point. So these are all the terms are going to study in this session in order to understand and effective way of drawing the cam profiles. As we know that, that there are various types of followers, and the various types of followers are one of the follower is knife edge follower, and another follower is roller follower, and the third type of follower is flat faced follower. Okay, flat faced follower, and these followers are having a different motions. These followers are having different motions. Coming to the picture of various types of motions, the various types of motions of any follower is having. One of the motion is that uniform velocity and uniform velocity. And the second one type of motion is simple harmonic motion. And the third one is uniform acceleration and retardation. These are the type of motions a follower can have. These are the followers. So in practical, the follower can be evolves because these cams are attached on a solid circular shaft. When the cam is rotating, what is the cam? A cam is nothing but a oval shape of a disc, is used for controlling the valves in the case of a 4-stroke internal combustion engine. Now, here, in order to draw the profile of a cam by considering the angle of rotations and the lift and the type of follower and the type of motion of the follower, we are going to draw a cam profile, the shape of a cam. Okay, in order to draw that shape of a cam, we have to know certain terminologies. Those terminologies are useful to draw the cam profile. Okay, for that, what is the first term we are going to learn is here base circle. What is the base circle? This is all terms are included in one picture, but the dominant color indicates the base circle. Base circle is the smallest circle that can be drawn to the cam profile from the center of the cam. Now here, base circle, what is the importance of base circle here? Base circle is the circle, the reference circle for the drawing the cam profile diagram. Now, base circle can be drawn by using a minimum radius of a cam. Now, when the cam is rotating one revolution, that one revolution of rotation of the cam makes 360 degrees. this 360 degrees is divided into 360 degrees is divided, that portion of the cam is divided into an angle of outstroke, angle during outstroke, angle during outstroke, and next to dwell, next to outstroke. Next portion is that angle during return stroke, and one more portion is that remaining angle, rest of the remaining angle is also a dwell. What is the remaining angle? Suppose in this angle during outstroke is making 90 degrees, and the dwell next to outstroke is also making 90 degrees, and angle during return stroke is making also 90 degrees. The rest remaining portion is the dwell after the next to the return stroke. That angle is how much here? That is 360 minus angle during outstroke. We are denoted by theta O. Outstroke next to dwell, theta OD. Return stroke, theta R. And this angle, the next return stroke angle, dwell during return stroke, theta RD, that equal to 360 minus theta O plus theta OD plus theta R. That is 360 minus 90 plus 90 plus 90. That is 90 degree. Okay, that these divisions will divide the circle, the base circle, in the case of a knife edge follower, and whereas in the case of a roller follower, we divide the same divisions will make it, that theta dwell outstroke, theta OD, theta R and theta RD, the portion of a prime circle in the case of roller follower. But whereas in the case of knife edge follower, here in this figure it is a roller follower. This is the follower which is having a roller. The follower, what is the purpose of the follower? When the cam is rotating in circular motion, the follower in touch with the surface of the cam such a way that when it is under rotary motion, the follower motion is under vertical reciprocatory motion, vertical motion. Now the cam is also a mechanism to convert the rotary motion into reciprocatory motion. Now the base circle, the importance of base circle is such a way that it is so important that without data given to the base circle radius, if we don't know, we cannot draw the cam profile. So it is the reference circle on which the cam profile will be drawn. The next definition is that tracing point. What is this trace point? Here we considered roller follower. Suppose if we talk it as a knife edge follower, what is the shape of a knife edge follower? It's very simple design, simple design, having a knife edge. Having a knife edge, and it is in touch with the cam. Okay, this is the cam shaft. So when the cam is under clockwise rotation, this knife edge is always in touch with the surface of a cam. When it is a rotary motion, circular motion, so it is in touch with the surface of the cam. So what will happen? The follower moves reciprocated motion up and down. So it is the axis passing through the axis of the follower is passing through the axis of a camshaft. Now, the surface, the maximum angle. Suppose this is the center up to this portion. This portion, the follower will rise, moves up. That is, terminology is that angle is outstroke, theta O. Next, for a particular rotation of, it is a constant circle radius, this is a dwelling position. At that time, there is no motion of the follower because it is a constant radius. To the next portion, suppose of this, next to this portion, the follower comes down. So, and a particle position, very small angle here, that is the return stroke during dwell. So, in this manner, the one rotation of a cam is divided into different portions of the angular displacements. Now here tracing point in this case is the point of contact with the cam in the case of a knife edge follower. Here in this figure indicates this is the roller follower. In this roller follower, what is the tracing point? The tracing point is the center of the roller. The tracing point is the center of the roller. This is the center portion. It is blinking. Okay, that portion is the trace point. In this case, in the case of a roller, this tracing point helps to draw the cam profile. How? This tracing point is the centers of the rollers, where we draw the roller centers by touching the surface of all the rollers. We draw a curve. The curve is known as a cam profile for the case of a roller follower. Okay, it is which point? To draw the cam profile, it is a reference point on the follower and is used to generate pitch curve, and also helps to draw a cam profile. So in case of knife edge follower, the knife edge represents the trace point on the pitch curve. And also very important, in case of knife edge follower, the knife edge represents the trace point, and this trace point is useful to draw pitch curve. So that pitch curve and cam profile both are same in the case of knife edge follower. Whereas in the case of roller follower, the pitch curve is different from cam profile, and the trace point is useful to draw a pitch curve only. That is that through the centers of the pitch curve, what we will do through these tracing points, we draw a circles, that roller circles. Through roller circles, we draw rollers. By touching the surfaces of the rollers, all surfaces of the rollers passing the curve, that curve is known as a cam profile. Now, the center of the roller, in the case of roller follower, the center of the roller represents the trace point. Okay, and one more important thing is that the pitch curve, the radius of the pitch curve, in the case of roller followers, the radius of pitch curve is greater than the cam profile radius. Alright. Now, that is the tracing point concept. The third point, if we see the third point, what is the third definition? Third important term is pressure angle. What is the pressure angle? It is the pressure angle. It is the angle between the direction of the follower. It is the angle between the direction of the follower and direction of the follower motion and a normal to the pitch curve. So, this is the direction of the follower motion and there is a curve here. Pitch curve is this a curve? And it is normal to the pitch curve. That angle is the pressure angle. Now, it is the angle denoted various letters. Here we are following with alpha. So, when one more important point of this alpha is when alpha is high. So, what will happen to follower? The follower will be jammed in its bearings. So, alpha should be the quality, that should be the value such a way that, or alpha should have a value such a way that the jamming doesn't take place in its bearings. So, and also this angle alpha, pressure angle alpha is very, very important in designing a cam profile. In designing a cam profile. So, very important, and through this pitch points, okay, through this pitch point, the point, what is the pitch point? Okay, it is a point where maximum pressure angle takes place. That point is the pitch point. Now, it is a point on the curve, which curve? Pitch curve, having the maximum pressure angle. So, in this figure, there are two pitch points are there. This is one and it is another one. Passing through this pitch point, if you draw a circle, that circle is known as pitch circle. That circle is known as a pitch circle. Again, pitch point is the point on the pitch curve having, very important term is that, maximum alpha, that is maximum pressure angle. But if the maximum pressure angle is increasing, if the alpha increases, the problem is that jam takes place. Jam, stuck up. Who will stuck up here? This follower stuck up in its bearings. That is very important. That's why alpha is maintained enough optimum value such a way that we can overtake or we can overcome jamming problem. We can overcome jamming problem. Now, the next definition is that pitch circle. It is the center of the circle. It is a circle drawn from the center of a cam through the pitch points. There are two pitch points are there. If you're passing through that circle is known as pitch circle. So these terminologies, this pitch circle, pressure angle, trace point, all these terminologies are very useful in designing a cam. In designing a cam profile. So the design of a cam profile, a geometry of the cam is so important in order to control the valve's motions. There are two types of valves in the case of internal combustion engines and in four-stroke engine. We can see two valves are there. One is inlet valve, another one is exhaust valve. This inlet valve and outlet valves are operated by this camshaft. And multi-cylinder engines. Okay, there are single cylinder engine, 4 cylinders, multi-cylinders. And if the inlet valve timings are different, inlet and exhaust valve timings are different, there severe knocking takes place and performance of the engine goes down. So this camshaft design of the cams are so important for increasing the mechanical efficiency of IC engines, internal combustion engines. Coming to the term of pitch circle, it is a circle drawn from the center of the cam through the pitch points. What is the pitch point? It is the point where the maximum pressure angle takes place. What is the pressure angle? It is the angle between the direction of the motion of the follower to the maximum normal to pitch circle, normal to the pitch curve. Okay, that is the definition of pressure angle and pitch point and pitch circle. So this pitch circle is so important. Next is pitch curve. This is the curve generated by trace point as the follower moves relative to the cam. For a knife edge follower, the pitch curve is equal to the profile of a cam, are same. Whereas for roller follower, it is different. It is not same pitch curve. For roller follower, pitch curve is different from cam profile. And whereas for knife edge follower, pitch curve and cam profile both are same. Okay, so as I told you, knife edge follower and roller follower, there is another type of follower is there. That type of follower is the flat faced follower. I am comparing only this roller and knife edge. What about flat faced follower? In the case of flat faced follower, also the pitch curve is also same as the knife edge follower, same as the cam profile. But one thing is that in the knife edge follower, pitch curve and same, both are contacting points. Flat faced follower, we will touch again tangential to the face, flat face, the face of the follower. How it looks like that, the flat faced follower, you can see at the end, the face is the flat face. So it is a flat faced follower. Okay, and this is flat faced follower, and it is a cam. Now the curve is generated by the trace point as the follower moves relative to the cam. For knife edge follower, pitch curve is same as cam profile, and whereas for roller follower it is not same, or it is differentiated, or it is separated by radius of the roller. This is the radius of the roller, it will be separated. This dark curve indicates the pitch curve, dark color curve represents the pitch curve, and it is the base circle. This is the base circle, and the base circle and the pitch curve is separated by this portion. That is the radius of the follower. Radius of the follower. Alright, in that manner, this is the way of understanding pitch curve. The next one is prime circle. The prime circle is highly useful in drawing the cam profiles when the follower is a roller follower case. But for knife edge follower, the prime circle and the base circle are identical. For a knife edge follower, prime circle and base circle both are identical, or both are same. But whereas roller follower, it is the prime circle and the base circle is separated by the roller, separated by the radius of the roller. Now here it is, the color of the curve here indicates that is the prime circle curve. In this prime circle, it is the circle drawn from the center of the cam through the center of the roller. This is the center of the roller that is passing through the tracing point. We cannot call it tracing point, but here it is the center of the roller. From this center of the radius of the base circle through the center of the roller and drawing a circle, that circle is known as prime circle. This prime circle is so important for drawing the cam profiles in the case of roller followers. How this is important? The importance of prime circle in the case of roller followers is, we have to draw a circle, we have to draw first prime circle. From that prime circle is divided into the angular displacements of outstroke and dwell during outstroke, theta r and theta rd. And this is the case when the axis of the follower is passing through the axis of the camshaft. Whereas in the case of offset, what is that offset means? The axis of the follower doesn't pass through the axis of the camshaft. This figure represents, in this figure, the axis of the follower is passing through the axis of the camshaft. That's why it is not offset. Offset is the offset by 10 millimeter means the distance from the camshaft axis and the axis of the follower is by whatever offset by 10 millimeters means 10 millimeter distance. Through the 10 millimeter distance we draw a circle. That circle is known as offset circle. So for offset circle, for offset axis, for drawing the cam profiles in the case of roller follower, it is not radial lines passing through the center of the cam to the divisions of prime circle. But here we will follow, in the case of offset circles, we follow offset cases. We follow the tangential lines passing through the circumference of the offset circle through the divided marks or tracing points or tracing marks of the prime circle. So while solving those problems, you can understand better the importance of prime circle, especially for roller followers. Now, it is the smallest circle mentioned, but it is the largest circle comparison to the base circle. But it is differentiated by the radius of the roller. And for a knife edge follower, as we have mentioned here, the prime circle and the base circle are identical. And not only knife edge follower and also flat face follower. This flat faced follower and the knife edge follower, base circle is same as prime circle, or prime circle and base circle both are identical. So that's why here we have shown for here roller follower case study, so that we can understand better what is a prime circle. So prime circle is so important for the cases of roller followers. Next, lift or stroke. In the case of lift or stroke of the followers, it is the maximum reciprocating distance, vertical distance traveled by the follower during the one revolution of a cam. For one revolution of the cam, what will happen here? The stroke, the follower moves maximum distance, travels and also comes back the same distance in return. The maximum distance traveling up, rising up, that happens there will, in the problems it will mention that, they may mention during that time the valves may be opening and next returning the valves may be closed. This all will be taking place. Now, this is the lift here. In this figure, we are showing you. This is the lift of the follower. Okay, the lift of the follower or the total follower travel. It can be in terms of millimeters, 50 millimeters or 60 millimeters, like that, etc. Examples I considered. So it is in linear reciprocatory. It is not in angular displacement, because the follower moves reciprocatory motion up and down. That is the linear distance. Now, so it is the maximum travel of the follower from its lower position to the topmost position. Okay, that is the lift or stroke. This term is related to the follower, and also it is dependent upon the angle of rising of the rotation of the cam. So it is dependent on the rotation of the cam. So it's very important in order to draw the cam profiles. The next term, we can see the cam profile. This is the curve. For the case of roller followers, this is the curve we have touched, we have crossed. Circumference of all rollers. Have you seen here? These are the rollers. This curve is traced by touching the surfaces of a roller. So here, these rollers we have drawn on surrounding. But in practical, this roller doesn't move. It remains, the follower remains fixed at position. To draw the shape of a cam profile, the methodology you are following such a way that these rollers are moving on the circumference of a cam like that, but no. So that at different positions, the lift of the follower takes place at a particular angle of rotation of the cam. So there is a diagram. The diagram is known as displacement diagram. This displacement diagram is the diagram of angle of rotation of the cam versus lift of the follower. So, per particular angle of rotation of the cam means, again, subterms outstroke angle of rotation, outstroke dwell during outstroke, and return stroke angle of rotation dwell during return stroke. At these strokes, the lift of the follower is what is the position of the follower position. During complete outstroke, again, outstroke begins from 0 to maximum value. And return stroke, theta maximum to, again, next consideration, it continues. But the sum of all these angle of rotation is equal to 360 degrees. So this is the profile of a cam. What are the terms we have studied here? The terms we have used, what is the base circle, what is the tracing point, what is the maximum pressure angle, what is the follower motion, what is the pitch curve, what is pitch point, okay, what is the prime circle, and finally what is cam profile. This cam profile is the shape of a cam. For this shape of for obtaining the shape of a cam, there are various parameters, input parameters are required. For drawing this curve, cam profile, various input parameters are required. The input parameters are angle of rotation of a cam, that is outstroke angle, theta O, theta OD, theta R, theta OD, and the value of the lift of the follower, and the type of the follower, and the type of motion of a follower, and all this. And one more important condition is that the axis, whether the axis of the follower is passing through the axis of the camshaft or not. If it is not, it is different. And type of motion of the followers, there are various types of motion of the followers, that is uniform velocity, and whether the follower is under simple harmonic motion or the follower is moving under uniform acceleration and retardation. So this type of motions, based on the different types of motions and lift of the follower, we draw a diagram. That diagram is known as a displacement diagram. This displacement diagram helps to draw the cam profile. Now finally, this is all terms, curves in one picture we can see. So what are the values here? What type of circles are important for drawing the cam profile? Base circle radius is required. Next, lift of the follower. These are the parameters are required to draw the cam profiles. Next, theta value of outstroke, dwell during return stroke, dwell during return stroke, and finally condition. What is the condition for axis of the follower is passing through the axis of the camshaft or not. Axis of the camshaft or not. So these are very, very important. And for drawing the roller follower, for drawing the cam profile, for the roller follower case, we need the radius of the roller. But remaining terms are useful for designing the cam. But these are the parameters are required for drawing the cam profile. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.